Dear colleagues, dear participants of the conference, I'm going to start this morning session, section presentations for the section number 4. And we invite to present
Владислав Кацовский.
presentation of ID 305, Vladislav Katsovsky, please.
Please share your
Share
screen.
your screen, yeah.
Can I share my screen?
One second.
Do you see my screen?
Yes.
Can I start? Yes. Thank you. Hello, my name is Vladislav Katsovsky. My co-authors are Vitaly Lazareshin and Tatiana Lisovska. Let me to present our report, Smoothie multi-threshold activation function in the learning neural net.
Please speak more loudly.
In the current slide, you can see the statement of the goals of research. Our work is motivated by the difficulties related to the learning neural network, classical continuous sigmoid shaped activation, such as logistic sigmoid and hyperbolic tangent, suffer from the vanishing gradient problem, as well as they have a saturation group. Modern.
Excuse me, can you speak more loudly?
Lovely.
Громче можете говорить? Или микрофон громче сделайте, пожалуйста.
Yes, I increase. Modern rectified Bayesian activations, such as rectified linear unit, leaky rules, or exponential linear units have the advantages. However, they are vulnerable to the Dine-Reus problem. More modern functions like SIL, Swish, GIL, or MISH have similar drawbacks. Multi-threshold activation functions provide the one of possible solution of mentioned problem. The application can increase the quality of modeling significantly nonlinear functions, which is based on the ability to represent more precisely the change of data using numerous levels of discretization. Most significant property of MTIF is its discreteness. Therefore, it cannot be employed in network architecture for which continuous activation are required in order to maintain the gradient-based learning technique. Thus, we need to apply some mapping in order to transform multi-threshold activations to the form that is acceptable for gradient-based optimization. One of possible solutions consists in the smoothing of discontinuous step function. It uses the transformation employing logistic sigmoid, and it's called logistic sigmoid smoothing. The example of such for different values of steepness parameter is shown in the right-hand side. Sound is better? Previous transformation has been obtained using standard logistic smoothing, but there are many other sigmoid functions which can be also useful for smoothing. For example, consider following two approaches. The first is obtaining by the use of hyperbolic tangent instead of logistic sigmoid. The second employs rational sigmoid. The example of all three kinds of smoothing and The comparison is presented in the slide. Basic properties of smooth activation function has been established in our work. Smoothed functions hold the same bound condition that initial step function before smoothing. Next, it has been obtaining that the tangent smoothing is a particular case of logistic sigmoid smoothing. Moreover, the smooth version of increased step function is also increasing. Backpropagation algorithm uses the chain rule for the calculation of gradient of the network loss function. The one of calculation step is the computing of the partial derivatives of loss function with respect to the activation function of the given unit. Thus, we need formulas for these derivatives when dealing with mean smoothed activation. They are presented in the current slide. Notice that we treat thresholds like trainable parameters, which are updated on each correction step. Under this assumption, we need also the formulas for partial derivatives with respect to thresholds, which are shown below. In order to estimate the capability of smoothed function in comparison with other popular activation, two series of experiments were performed. The first series, the ability of neural network with different activation function to solve the approximation benchmark task was considered. The list of considered activation is shown in the legend of diagram. The approximation task was solved on the multi-layer perceptron with two hidden layers containing 128 and 44 neurons respectively. By analyzing presented curves, we can conclude that logistic sigmoid Tench, Ryu, Swish, Mish completely failed to approximate benchmark function.
Okay, you have 1 minute.
Thank you. The second series of experiments consisting on the solution of the real-world regression problems on the liver disorder data set. We used 56061 MLP architecture. By analyzing obtaining data, it's possible to conclude the activation provided by the logistic sigmoid smoothing overperformed all other activation by both considered metrics. And conclusion. The main is that experimental results confirm that the use of smoothed activation function may improve the capability of neural network and reduce the cost of the network training. Thank you for your attention.
Okay. Thank you very much, Vladislav. So, do you have any questions? Okay, in this case, one more question is, can you tell me the application of your research?
I think that our research might have very wide range of application because designed activation function and are not intended to the particular problems. They can be employed for different network architecture, different tasks such regression, classification, function optimization, time series forecasting, and so on.
Okay. Okay, thank you very much. Mhm.
So,
Okay, thank you.
Okay, thank you, everyone. Thank you for your presentation. Now you can close the sharing of your screen. And the next speaker is with ID 308 from Kostanay Regional University, Ahmet Baytursunov. Maria Raspaeva.
Yes, I'm here. Good morning, dear participants. Do you hear me well?
Yes.
Yeah.
Okay,
Could
great.
you share your screen, please?
Yes, sure. Do you see my screen?
Yeah, we can see. Yeah, now you can start. You have 6 minutes and 1 minute for Q&A.
Okay, my name is Maria Raspaeva. I'm from Baytursunov Kostanay Regional University. I'm a PhD student, and with my supervisor, Olga Salikova. So we are pleased to be here to present our paper entitled of Effect of Data Balancing Methods on MRI Alzheimer classification. So the background of this research is Alzheimer's disease is a progressive neurodegenerative disorder that leads to cognitive decline, memory impairment, and challenges in daily activities. So the problem is that we have a data set which is highly imbalanced to the majority classes. And in this figure, we can see that the non-demented and very mild demented majority classes and moderate demented is underrepresented classes with just 64 images. So if we classify this data set, the results will be biased. And the solution was to generate synthetic images. And we applied the generative adversarial network to synthesize images. And here on this figure, we can see the results of the brains. However, in this paper, we do not focus on the GAN itself because we focus on the classification task. So a year ago, we published a paper with the methodology of the GAN. So here we present the model architecture for the classification task. The input class of size of 128 by 128 pixels, they are grayscale images. And due to the reason that all pre-trained models in the transfer learning request to replicate to RGB models, so we transformed grayscale images to the RGB images and trained with pre-trained models. As a result, we received 4 classification results with labels 0, 1, 2, 3. We trained our 6 models in 3 modes. The first one was no augmentation. So we trained the dataset as it was. And we received the results, the highest result with DenseNet network, just with 84% of accuracy. It's not so good results, but without any augmentation anyway, 84%. The second mode was applying traditional augmentations such as cropping, rotation, translation, and etc. And in this mode, the highest accuracy was received by exception neural network with 95%. However, the highest results were received with synthetic data applied in 2 models, EfficientNet before and exceptionally with 97% of accuracy. Moreover, the ROC IUC under area under the curve performs the highest values. So why do the architectures perform differently? Because ResNet is a very deep model prone to overfitting on imbalanced data, and it requires careful fine-tuning of the hyperparameters. VGG19, it's outdated model, and the last two, EfficientNet and Exception, they are modern, robust, and they are robust in the small data set. And what is the most important for medical data, they are robust to imbalanced data. So how do data balance methods affect the MRI Alzheimer's classification? So the results received that without augmentation, we had poor accuracy due to class imbalance. When we balance the data set with traditional augmentation, results improved significantly. However, the synthetic images presented their highest values of their accuracy. In both models, EfficientNet before and Exception. The future work in our research is to investigate hybrid augmentation strategies, explore ensemble models, and we pay attention that we want to integrate not just 2D images, but also 3D MRI data to capture spatial relationships more effectively. And clinical practical issue to validate our data on the clinical in the clinicals of the hospitals. So that's it. Thank you very much for your attention.
Thank you very much, Maria. So, any questions? Okay, I have a question. You use binary classification or you use a multi-class classification?
It's a multi-class classification because we have 4 classes in the dataset.
What classes?
Here in the figure, this is the class distributions on the datasets. Mild demented, moderate demented, non-demented, and very mild demented classes.
I see. But I mean that maybe Alzheimer's disease is similar to other types of diseases, but not related. Maybe other diseases related to brain corruptions. So, do you consider these types of diseases?
Other diseases, actually, we are still doing our research, and MRI classification, it's just a part of the big research. And now we are preparing our paper about breast cancer in ultrasound and mammography domains. So not just MRIs. So MRI is just an additional application of our research.
I mean that maybe we have similar features, we have similar symptoms for other types of diseases. Maybe not Alzheimer, maybe cancer of brain or other types. So
yes,
false positive samples. So how your approach struggle with these types of diseases?
Actually, in the medical dataset, we should train on that disease what we want to receive the results, and of course we can transfer our model, our results to the other disease. However, we should be aware about the areas that it's medical domain, because we should be we should pay attention, because it's about health of the patients. of course, we can transfer features to another dataset because we're using transfer learning. The main idea of transfer learning is to transfer features from the ImageNet dataset, the big one, with around, I don't remember exactly, 15 million of images, to the small datasets like MRI, Alzheimer, breast cancer, chess, and other datasets. So yes, we can transfer.
Thanks a lot for your interesting presentation. So we should move to next speaker. Thank you.
Okay, thank you very
Dean.
much. Thank you very much.
Goodbye, Marat Nurtas, Ayarjan Kumarkhanova, Takmina Nesipay. Please, are you here? Or okay. They will present offline. Yeah.
Sorry, could you stand closer to the microphone, please? Thank you.
I will present our work on estimating acoustic images using deep learning on seismic waveform images. So in the next 6 minutes, I will cover why this matters, what we set out to do, and how we did it, and what we found at the end. So first of all, I'm sure that all of us know what earthquakes are and what consequences they have. And secondly, the main thing that we all should know that there is still no single official method that can forecast earthquake. That's why all the research around the world trying to find different solutions to forecast such nation phenomena. And let's learn some statistics. We know that annual economic losses because of earthquakes is about $38 billion, and we all probably remember the situation that was in Turkey, where like massive earthquake killed many people, which was like highly populated place. It's not only about Turkey. We have a lot of such mega cities that are located in dangerous seismic zones, such as like Japan and Almaty, which you can see from this map, where Almaty is frequently subject to such massive earthquakes. And did you know that due to the man-made impact, tectonic movements, and global warming, the amount of earthquakes is increasing every year, which you can see from the above chart. So that's why it's very important to find the solution. Because existing methods in practice nowadays, such as like early warning systems, they can predict forecast earthquakes only 1 or 2 seconds before the earthquake, and they have limited accuracy. That's why our goal is to use deep learning model to help this field. So we will develop a deep learning hybrid model. We'll take waveform images, which is based on early warning system, and help to improve performance. So for this task, we use Stanford earthquake dataset that like consists over 300,000 waveforms, seismograms, and each of them 50-second record, which has like say markings, annotations, which is P wave, S wave, and encoder marking. But first, let me explain what they are. When like earthquake happens in the deep layers of Earth, it like generates two main waves. P wave is come first to the surface of the ground, and there is located like seismic sensor which pick up such waves, and this P wave, which is the one used for, but it doesn't cause any damage. And the next S wave, secondary wave, it comes later, but more powerful, and it can cause destruction, which is where visualized using red line. So we will use such images, such waveforms, and we will pass through the deep learning model, which will like help to estimate the magnitude of the. So in such way, early warning system works because they take this P wave that come first, and they use statistical and empirical tools to estimate the magnitude of the secondary S wave. So we did some proposing steps such as like reducing the size of the data set because of like limited computational resources, then splitting and normalization as usual. So from this slide, you can see our model architecture of CNN-DLSM, and you can see from here all the details. Overall input of our model is waveform image, which pass through first from CNN block, which help to capture special features. Then it will pass through LSM model, DLSM, which captures like temporal dependencies. Then overall output is like magnitude. From this slide, you can see some settings of that we use to train our model. The main thing that we used earlier is logging to prevent overfitting. So from this loss, you can see the generalization process of our model of loss, and we used two metrics to measure our performance, MSCI and MIF. Also, we compared our results with other existing solutions. And from the last column, you can see the performance metrics, and you can compare. And our using this comparison, we can say that our image processing and DLSM model achieving like just that was just trained on 10,000 images is competitive with other like existing solutions methods, and this is very promising result because we planning to move raw in future in raw waveforms, not images, which will like help us to improve our results. So from this table, you can see you can get some information about our workflow time metrics. And in conclusion, I want to say that you can see CNN-DLSM effectively estimating magnitudes from images. Of course, it does not forecast earthquakes in advance of days, but it helps to maximize and improve the performance of early warning system. So that's why it's for attention.
Thank you very much, Nina, for your very interesting presentation. So, any questions, please?
What is the rate of Kazakhstani data in this Stanford dataset?
In this Stanford dataset is not included Kazakhstani regions because this in this dataset we have like seismic stations that are located in the world but not in Kazakhstan. So
How do you think is it possible to implement for Kazakhstan your model?
yes, of course, but I think not using waveform images, but we can use historical data such as like where we have information about time, like longitude, latitude, and depth of the magnitude. We can use this information to predict also magnitude.
Yeah.
Nowadays, do you have some experiences?
Yes. I worked with like this historical data for Almaty, for Kazakhstan, and we're trying to like find solution because this step, this presentation was also like this work was also one of the steps of our larger system because we're planning to build such systems that will have different models, and in real time it can predict like earthquakes. We want to create such system.
So you plan to expand your work with Kazakhstan data. Thank you very much. It's very actual and very interesting presentation. So we should to move to the next presenter, Aydana Zalgas, Islambek Kurakbay, Akbar. Are you here?
ID 332.
Yeah, they are online.
Islambek, please share your screen.
Hello, everyone. Can you hear me well?
Yeah.
And can you see the screen?
Yeah.
Okay. I may start, right?
Please. Welcome.
Hello, everyone. My name is Islambek, and I'm today presenting our paper called Detection, Segmentation, and Classification of Tooth Cavities based on medical records. We are from Astana University, from Astana. So the relevance of this topic is because 90% of all adults aged 20 plus years have had at least one tooth cavity, and each fourth person has untreated tooth cavity. So we propose the solution to provide early animal detections and to enhance diagnostic accuracies by enabling remote dental assessments and providing detailed quantitative insights using computer vision and machine learning solutions. Our aim is to develop the computer vision solution for detection and segmentation of tooth cavities and classifying and tooth animals using medical X-ray records. Our objectives are data collection, analysis and pre-processing, and artificial intelligence and machine learning model development, evaluation of model metrics, and our results. We collected two types of data. The one is pre-processed and labeled images from Dentex 2023 dataset, which contains 2,332 images of different categories of tooth cavities, including caries, deep caries, and impact teeth. We also have the panoramic dental dataset, which has 100 labeled X-ray images, which look like this. And the second type is the unlabeled data we collected from the local clinic named Calibrix, which provided us 130 real patients' dental images, and we tested our solution on this data. We provided data augmentation, techniques such as image degradation, image flipping, transliteration, and etc. Our processing steps are, first of all, we classify the quadrants of the jaw, upper and lower jaws. After that, we detect each tooth by using our CV model, and then we detect the dental disease on each of these tooths. And lastly, we provide segmentation techniques to detect the impacted teeth. So our output data in the first step looks like this. So this CV model detects the 4 quadrants on the jaw and labels them in this order. Second step, so for each quadrant, we have 8 set of tooths. And for each of these quadrants, we label them using our CV detection model. Third step includes multi-class classification, which classifies each of these impacted teeth by 3 categories: caries, impacted, and deep caries. And lastly, our segmentation model inputs the X-ray image and outputs the impacted teeth. So you can see here the ground truth mask and unit our prediction of the CV model. And it's a high accuracy model. So for segmentation, we used UNet segmentation model, which we obtained accuracy of 97.5% and recall 95.72%, and the precision of 96.17%. For tooth detection and quadrant detection, we use YOLO V8 architecture. And for quadrants model train, we obtained 80% of model precision. And this is how our normalized matrix, confusion matrix looks like for each of these quadrants. And the same for detection of the tooth. Okay, so for disease detection and classification, we also use YOLO V8 model. And this is our final result from unlabeled image that we use from Almaty Dental Clinic. And you can see here that this model detected 2 problems with this image, and also label their quadrants, label their tooth number, order, and the disease type. In conclusion, we collected dental images from both web and local dental clinics. They contain labeled and unlabeled images. We applied data augmentation techniques such as resizing, translation, and normalization to our images. We developed models for detecting and segmenting tooth cavities and classifying anomalies using both machine learning and computer vision models, which include detection, classification, and segmentation. We evaluated models with metrics such as precision, recall, F1 score, and accuracy. And lastly, we developed a system for dental X-ray image analysis and provided model predictions for test images from the dental clinic dataset under expert mentorship. That's all. Thank you for your attention. If you have any questions, please.
Thank you. Islamberg. Any questions, please?
Maybe our participants have question. Okay, I ask. So, what is principal difference of your work from other works in this field? What
Okay.
is the main difference?
The main difference is that we used all of these machine learning computer vision tasks. These are detection and classification and segmentation. We also provide end-to-end solution from unlabeled image to detection of quadrants, detection of tooth, detection of problem with tooth, and the segmentation. So we include all varieties of computer vision tasks, and we unify them in one solution.
Thank you very much. The next presenter is Ahmira Sagatbek, Amina Sidahmetova, Pakizar Shamoy. Are you ready? Okay.
Yes. Good morning. Let me share the screen.
Welcome.
Can you see it?
Yes, we can see. Thank you.
Okay, let me start. So, hello everyone, my name is Ahmira Sagatbek, and I will present the research named Comparative Analysis of Clustering Algorithms for Human Consistent Dominant Color Extraction. We did this research together with Amina Sidahmetova and Pakizar Shamoy at Kazakh British Technical University. So, this is the content that I will cover today, and let's start. Color plays a crucial role in our lives. It shapes the emotions, cognition, memory, and decision-making. And nowadays, there are color extraction techniques that don't align with human perception. It is because they rely on pixel frequency, and as a result, visually significant but small color regions are ignored. That is why our research aims to evaluate clustering techniques used for dominant color extraction and assess which aligns with the human visual perception. So in this study, we evaluated 6 clustering techniques: RGB histogram, K-means with custom color space, fuzzy C-means, hierarchical, and optics clusterings. And then we, for the image dataset, collected 20 images with different level of complexity from various sources like dataset X, FreePic, and self-captured images. These images were provided in the survey that was conducted through Google Forms and involved 128 participants. They were asked to choose a palette or palettes that best represent the image. And for the voting system, we defined a score that the formula is shown on the screen. And here the I is the total number of images, Vij is the number, how frequently the palette was picked, and P is the total number of participants. So as a result, we get this table, and we identified that hierarchical clustering showed the highest selection rate, which is 0.356, and followed by k-means and fuzzy c-means clustering. Here we can see the bar chart that shows the distribution of the consensus percentage for different images. And as we can see here, image number 8 showed the highest consensus, this image, and the majority of the participants, which is 78.9%, showed the palette number D, which is hierarchical clustering. The reason why hierarchical clustering showed the highest human alignment, it is because it is tree-based structure, and it handles the visually significant but small color regions. So as a conclusion, I want to say that our study evaluated 6 clustering techniques, and we identified that hierarchical clustering achieved the highest perceptual alignment. And in our future work, we plan to expand the data set and, of course, refine the clustering techniques further and develop the adaptive color extraction model. And overall, our contributions help to make the color extraction more human consistent. So it is valuable for the areas like image processing, design tools, and visual medias. So here's the reference list that we used, and thank you for your attention. If you have any questions, I'm ready to answer them.
Thank you very much for your interesting and so high qualified presentation. So I have one question. Is the moment of random selection in your methods?
No, basically we did the literature review, and after that, the reasons why we chose exactly these clustering techniques, it is because of their range of strategies. Like all of them have different implementation. That is why we decided to choose exactly these methods.
Hierarchical clustering, yeah. But we know that k-means or other clustering approaches start with random points. So is your approach?
Yeah, because we wanted to do the just comparative analysis to find which one is in the beginning more human aligned with human perception, and in the future we plan to make the model which will fully be similar with the human perception. And for this we did this analysis to identify why RGB works so bad. It is because of they rely on pixel frequency, and it usually takes the large areas of the picture of the image. So this was like a comparative analysis work.
Thank you very much for your presentation. So any questions, please? No questions, so we should move to the next presenter. Marat Nurtas, Alexander Fremt, Bigzat Bukhatov. Are you here? Yes, thank you.
Yes, I'm here. Can you hear me?
Yeah, we can hear and we can see your presentation.
Okay. So, good day, dear colleagues. My name is Bukhatov Bigzat. I'm presenting collaborative work with Marat Nurtas and Alexander Fremt titled Comparative Analysis of Deep Learning Architecture for mineral deposit segmentation using multimodal. In geological exploration, traditional methods are still commonly used to search for new mineral deposits. This include drilling, sample analysis, and satellite observation. Despite their effectiveness, traditional methods face several challenges: high costs, depends on expertise, and lack on scalability on processing large areas and data sets. So modern digital methods offer new possibilities. It's improved feature extraction and reduced noises, automated interpretation, and greater scalability and lower cost. So mathematically, we treat this as a semantic segmentation problem. We have input multi-channel images, output we have binary masks, and we have models that F means model. Our goal is to predict for each pixels whether it belongs to a deposit area. So related to work convergent. So however, with types like hyperspectral or radiometric data, this provided useful for inspiration our approach. So how do we evaluate the performance of our models? We use F1 for balances, precision and recall, and the intersection of union measures how well the predicted max overlaps with the true scores. So about data, we use real data from the Storgay basin. These maps include geological, terrain, magnetic field, thermal field, and gravity field maps. So now moving to preprocessing, we began by realizing all maps to common resolution. This to standardize our super resolution neural networks. For example, is and to preserve fine details. Then we one of the maps convert to grayscale, manually marked the deposit zones with bright.
It seems that you have a bad internet connection. I'm sorry.
Use CV.
Exact. Can you hear us?
Slides.
Yeah, it seems that we have a bad internet connection. Maybe.
Yes.
Could you explain this slide one more time, please? Dear participants, it seems that our presenter, our speaker with ID 334 will be re-explain his research after one speaker. The next speaker is.
I'm sorry, I'm here.
Bigzat, are you here?
Yes. So about
seems that this internet
this
is
slide.
unstable.
So
yeah, Bigzat, I'm sorry. If it's possible, could you move to the previous slides and could you explain it one more time because we didn't hear the last slide.
Okay, we start with preprocessing. We began by resizing all maps to standard of these pixels using neural networks such as super resolution networks to preserve fine details. Then we preferred our iterative visual alignment, manually overlaying the maps until all geological features match precisely. So after that, we took one of the maps, convert to grayscale, manually marked the deposit zones in bright yellow, then used OpenCV to extract automatically our mask. So the next is label removal. We need to remove all the labels, so we use algorithms such like ESRGAN, Llama, and others from our thesis, and we just remove all the labels, all the annotations. So the next one is we have pixel fragments with overlapping between main squares. After then, you can see example of our formats.
One more time.
So the next one
Sorry, Begzat. Could you explain the previous slide one more time, because it seems that we didn't hear. Yeah, previous, the 11th page, please. Yeah, because we didn't hear the explanation of this page. Yeah, could you explain one more time, please? Thank you.
Okay, our images is very large. We divided them into 128 pixel fragments with 50% overlap splitting vertically and horizontally. Also, we separate this between my square to better contextual information. So the next one is we can see simple example of what mask look like after splitting. After that, we split and augmentation our maps with this type of augmentation. We manually divide them with train, validation, and test. So we have this count of training set, validation, and test. So the next one, we start with our creating our own CNN models. This architecture was inspired by those in the literature, but we couldn't directly use existing ones. Difference of our formats and limited data availability. So we adapt and simplified them for our task and data set. So we have basic results and we have a model configuration you can see. Also, we have training graphs, loss training and accuracy during our training. The next one is ROC-AUG. You can see that attention base produce steep ROC curves in the low false positive rate region, and crucial advantage in manner exploration where missing a deficit is a costly error. So you can see also confusion matrix. You can see that CNN with attention exhibits significantly fewer false negatives. The next one is we also use another type of models is classical architectures like UNet and advanced models like PSPNet, HNet, SegNet, and other. We can see that top performing architectures is ResNet, Deep Lab, fast training, robust performance, and high validation stability. So the next is also ROC-AUG. We can see that residual collections and attention mechanisms significantly improve model confidence and generalization. More complex architectures are not always better. In our scenarios with limited geophysical data, ResNet and Deep Lab shows best trade-off of complexity and performance. Also, we have confusion matrix. So of our results is ResNet and AttentionNet offers the best balance. BaseNet may be suitable for use cases where not missing any deposit, but despite the complexity, UNet++ and HRNet outperform the simpler models in real-world conditions. So we can see the results in our metric comparison. So the best model became ResNet with accuracy of nearly all true deposits, produce very few false positives, and maintains consistent class separation. So yes, we are aware of recent advances in high-speed architectures like YOLO and other real-time firms, but those models are optimized for applications such as real-time processing. But in our case, we need maximum segmentation accuracy, minimal deposit omission, and stable performance on large geological imagery. So we have also an example of results. Our models, in conclusion, we comparative analysis of certain deep learning architectures. The models were trained on multimodal geophysical data. Also, we applied processing, augmentation, and manual region-based data splitting to avoid data leakage. And the main result is ResNet demonstrates the best overall performance across all metrics. So the next is literature review. And thank you for your attention. I will be happy to answer your question.
Okay, thank you for your presentation, Begzat. So, dear participants, do you have any questions?
Officially lists, please.
Okay,
How
Begzat,
result?
in this case, can I ask one more question, which is about your sources? And so, and the sources to provide your calculations, and how do you validate your results? Can you hear?
About how to about what my sources maps
Yeah, yeah.
or
Where did you get this data for your source, and how do you provide validation for them after calculations?
first of all, about our source data, Alexander Fremt gave it to us. He is working in Almaty, National Scientific Center for Seismological Observation and Research. It's close data set.
And for validation, do we have any observed data set? Is it possible?
How we validate? See, can you hear me?
Yeah.
Can you hear me? But what absolute do you mean?
So, how do you validate your obtained results?
We unfortunately we can't find exactly the same work, so we just using all our data. We train models from other literature. So and we validate them with mean accuracy, mean F1, mean intersectional reunion. If you are about real world validation, so our data is real world, but we can use our models for other type of maps, for example, in Kaspi or other region, but we need additionally search for them.
Okay, thank you.
Okay, thank you for your presentation, Begzat. Now you can stop sharing. So our next speaker is with ID 340, is our distinguished professor from Narkhoz University, Yershad Sapajanov. We are very glad to see you here. And could you start your presentation, please?
Yeah, just a minute. I hope you can hear me well.
Yeah, we can hear you.
Yeah, good. So,
And we
yeah,
can
I
also
can hear you. Please, can you tell me what type of, or what do you see on your screen, if I'm sharing the right screen?
Yeah, we can see your whole screen.
That's good.
Like, is it reinforcement learning? Is it my presentation?
Yeah. And
Okay,
we just want to kindly remind you that you have 7 minutes for presentation and 1 minute for Q&A.
Okay, thank you. So hello everyone, thank you for joining, thank you for being here. First of all, I want to tell you about my team. So here you can see we are from different universities, from different countries. So we try to do some good job within this project. So let's go for our work. So I'm presenting you our work on how reinforcement learning and genetic algorithms can help us fine-tune PID controllers, especially in a nonlinear and noisy environments like temperature and control systems. Okay, so precise temperature control is critical in industries like chemical plants, semiconductor manufacturing, and HVAC systems. Most of these systems still rely on PID controllers. They are simple, reliable, and engineers still trust them. But when the system becomes nonlinear, or when there is a sensor noise or delays, the traditional tuning method starts to struggle. These growing demands for smarter adaptive control strategies is why AI-based PID tuning methods are becoming existing or exciting research direction. Let's go next. But even though many AI-based PID tuning methods are being developed, most studies don't directly compare them with classical methods under realistic conditions. Nonlinear systems with varying heat dissipation, noise, and delays are often avoided because they are hard to model and control. So our work aimed to fill this gap by systematically comparing both classical and AI-based PID tuning methods in a carefully modeled simulated nonlinear temperature system. So our main objectives were first to compare classical methods like Ziegler-Nichols, ZN, Cohen-Kuhn, CC, and AI-based genetic algorithm, and RL, which is reinforcement learning for PID tuning approaches. Second, we wanted to test them under various levels of nonlinearity, sensor noise, and control delays. And finally, to identify which method is the most robust, efficient, and practical for such challenging systems. Okay, let's start with our, from the beginning, right? Our system is based on the Newton's law of cooling, but we extended it to make the heat dissipation coefficient change with the temperature. This adds nonlinearity to the system. We also added Gaussian sensor noise and control delays. These are common in real-world temperature control systems. This addition made the system much harder to control and a good test case for tuning methods. Okay, we use this. We use the standard PID control formula, which you can see here. Which is P stands for proportional, I is integral, and derivative, D is derivative of the error between the desired and the measured temperature. I think that would be enough here. As far as our method, so here we wanted to compare two classical methods, which is Ziegler-Nichols, Cohen-Kuhn, and AI-based methods, which is genetic algorithm, reinforcement learning, and we wanted to incorporate a little bit noise estimation and domain by adding Kalman filter to reinforcement learning algorithm. How we assessed, how we evaluated if our model is good or bad. So we have here basic or main 5 criteria that are very important. So RMCE, ITAE, of course, energy consumption, of course, settling time. Based on that, we can also compare. So actually 4, 5th is just we are I'm telling that accuracy, stability, energy, efficiency, and just okay. Let's go. So here is first result. So I just wanted to show you with low noise and high noise. So here you can see under the in low noise conditions, genetic algorithm, I hope you can see that, had the best performance across all matrices. It was accurate, stable, and efficient. As far as classical methods, they struggled a lot. They showed oscillations and were very slow to stabilize, which is not good. Even with the Kalman filter, reinforcement learning algorithm had trouble staying stable. That's why in this case, I think that genetic algorithm is the most balanced method. As far as high noise, again, when we increased the sensor noise to simulate harsher conditions, genetic algorithm, as you can see, remained stable and most robust. Reinforcement learning methods degraded significantly. They needed more control effort and showed instability. Unfortunately, classical methods were not good. And they are less practical due to settling time. Okay, and here on this slide, you can see overall comparative summary, which I'm not going to read. So you can just read and compare by yourself, and you can choose the best model if you think that my conclusion is not Good enough. So here, the general conclusion is our work shows that genetic algorithm is currently the most practical and robust PID tuning method for nonlinear temperature control systems. As far as reinforcement learning methods, despite their potential, they are still computationally demanding and sensitive to real-world disturbances. For critical applications like safety systems or embedded controls, genetic algorithm is safer and more scalable option today. As far as our future work, I hope that we will add another variable, which is time delay, which will make our algorithms to struggle more. And I wanted to compare and see what will happen with them in the future. So that's all for my presentation. If you have any questions, you are welcome.
Thank you for your presentation. Dear participants, do you have any questions?
Okay. Could you please expand your plans about future investigations?
So I just can't tell you my plans, but I still unfortunately didn't. So we didn't get good results yet, but it is a part of the project that we want. So in the future, we want to add time delay. So we have settling time, right? We have, for example, if you will talk about AC use in the room, so we want to set specific temperature that we want our room to be. So sometimes our pipes might be too long. That's why there might be some time delay happen, and we want to add this coefficient, and we have this variable which will make our model a little bit different. And as far as our system is non-linear, it is not easy or almost impossible to solve it with Laplace transform. That's why we need to think about this type of machine learning algorithms. So unfortunately, we don't have good results yet, but it is our future plan.
Thank you. It's good motivation for the future research. So thank you again. So we should move to next presenter.
Thank you. Yeah, you can stop sharing.
Nurlan Abdulbekov will present from the class.
Could you stay closer to the microphone, please? Yeah, thank you.
Good morning, everyone. Our title is Revolution Convolution Commonwealth Networks for Lung Cancer Classification. So our task is multi-class image classification. And one more moment about background of our research is like, let's look at the statistics. By mortality rate, lung cancer is leading among the cancer types. Yeah. So why not to automate the process of cancer finding? Yeah. Here you can see the three classes of cancers. First is adenosarcoma, yeah, and other types of the cancer, lung cancer tissue. Yeah. Next, our research motivation lies on the why not to use MLP alternatives like Kolmogorov armored networks, which doesn't have the conventional weights and the fixed activation functions. And it allows us for accurate and interpretable modeling of the our problems. Yeah. So you can see here that instead in the edge, instead of weights, we have planable activation functions using the B splines. Yeah. And in the nodes, we have some operations which you can see here some mathematical formulas. First is like our Kolmogorov-Arnold representation theorem. In MLP, which lies in the universal like approximation theorem, here it lies on the Kolmogorov-Arnold representation theorem, which approximates functions. Yeah. One more advantage of this approach is that we don't have the fixed activation functions. Instead of that, we have in every forward approach, we parameterize our functions, and it already have breakthrough in the so-called symbolic AI, and it is very interpretable model. It is not like MLP-based black box model. So you can here also see the kernel formulas and convolutional formulas. Here is our model architecture. Yeah, you can see here, and let's move. Here is from our source code, and it is like our convolutional model layer, and you can see some parts of that consisting part. And for baseline models, we want to test, and our model showed comparative results compared to baseline models with like CNN and ResNet. And here you can see that it has some overfitting stuff there, but it converges lately. Here, in comparison our model, one more thing that we noticed that here we can see that here is 10 epochs and there is 20 epochs, and even that less epochs we converge faster. And one more thing that we noticed also is that you can see also the graph count interpretation of our model. One more thing that we notice is also that we have reduced number of parameters in our model because of usage of B-splines. But it has some drawbacks. It tends to overfit to the data usually, and training time is slower than MLP counterparts, but it can be changed with changing our B-splines to some alternatives like radial basis functions and other alternatives. And there is possible opportunities for interpretation of convolutions itself. Currently, we don't have breakthrough in that field, but we tested, we visualized every B-splines in forward pass, but it didn't give us some interpretation insightful results. But it has some opportunities in the future. Thanks for attention.
Thank you very much. And did you perform any experiments?
Yeah, we experimented on this dataset, which I showed first.
I mean, results.
Results. Yeah. Results. We reached the 95% accuracy, which is very comparable with the baseline models, our baseline models. Yeah. And you can see here also our conclusion, what we noticed during our experimentation.
Do your West participants have any questions? No. So this work is the part of more larger work, maybe in project.
Yeah. In previous work, we used other data set, but in the renewable energy field, and we developed digital twin of solar station. And but in previous work, we didn't use convolutional part of the Kolmogorov part networks. And in this work, we expand our research and added some convolutional parts. In the previous work, as a feature extractor, we used some baseline models like EfficientNet. And here we noticed that it has some good comparable results to MLP counterparts.
Thank you very much. So, the next presenter, Jadra Erkan, Madina Suleimanova, Madina Mansurova, are you here?
Good day.
Good day.
Минуту.
Please turn on your camera and share your screen.
Yes, of course. Yes.
If you need more time, we can move to our next presenter. Okay, it's okay. Jadra, please, turn on your camera for the requirements of IEEE. We can see your face. Oh, that's good. Thank you. Please start.
Good afternoon. My name is Jadra Erkan, and I represent Al-Farabi Kazakh National University together with my co-authors Madina Suleimanova, Madina Mansurova. I would like to present our research titled Prediction and Analysis of Cardiovascular Diseases based on EKG images using computer vision algorithms. Let me begin by briefly framing the context of our work. Cardiovascular diseases, or CVD, are the leading cause of mortality worldwide. According to the World Health Organization, approximately 17-18 million people die from the heart-related conditions every year. CVDs are no longer limited to the elderly. An increasing number of younger adults are affected, placing a growing burden on global health system. Electrocardiograms. This study aims to develop and evaluate deep neural network models based on convolution neural network, CNN, and ResNet architecture for the automatic classification for electrocardiogram EKG images and the diagnosis of cardiovascular disease. Electrocardiograms remain one of the most essential diagnostic tools in cardiology. They provide critical insights into cardiac activity and help detect abnormalities such as arrhythmias, myocardial infarctions, and heart blockages. And we the dataset, we used the dataset, a publicly available dataset from the National Heart Foundation of Bangladesh. The dataset contains EKG images divided into 4 clinically relevant categories. These are normal EKG, healthy individuals, and abnormal heartbeats, including arrhythmias and acute myocardial infarction and history of myocardial who have history of MegaHav, and we developed and evaluated two models, CNN and ResNet. CNN built entirely from scratch, and ResNet using transfer learning, leveraging pre-trained ImageNet weights. Let me first discuss the methodology used for the custom CNN. All EKG images were resized to 224 by 224 pixels to standardize input size. Pixel values were normalized to the range 0 and 1, and we applied one-hot encoding for the multi-class classification task. The dataset was split into 80% training and 20% testing using a stratified approach to maintain class distribution. We trained the model for 10 epochs using the Adam optimizer and categorical cross entropy loss that we can see of the figure 1 and figure 2. Now moving the results. During the few epochs, the model showed modest performance with an initial training accuracy of around 28%. However, by the fifth epoch, I had already, you can see it, I had already reached over 81% training and 92 validation accuracy. From the 7th to the 10th epoch, the model's performance continued to improve, culminating in a training accuracy of 100 and validation accuracy of 28%. To validate these results, we analyzed the confusion matrix. But I want to about ResNet. Next, let's consider our second model, ResNet 50 with transfer learning. Despite the constraints, ResNet 50 still performed well. It achieved a training accuracy of 83% and validation accuracy 81%, reflecting strong generalization capability. Its training and validation loss decreased steadily over the epochs, indicating stable convergence without overfitting. The results show that deep learning models based on convolutional neural networks can effectively classify EKG images and detect cardiovascular disease. The CNN model demonstrated high accuracy, while the ResNet 50 model offers better generalization due to its pre-training on the large ImageNet dataset. Notably, both models can be further improved by increasing the training dataset size and exploring more complex architectures.
Thank you very much.
Any questions?
Okay, thank you very much. Dear participants, do you have any questions? Yeah, please, we have one question from auditorium. Yeah. Jadra.
Timirovich, please come here. We need to be closer to microphone.
Fortunately, yeah.
Good afternoon. I'm a doctor. I'm a cardiologist, doctor.
Oh?
Are you hearing?
I don't hear it clearly.
Are you here?
Yes, I
Zadra?
hear.
Zadra, good afternoon. I'm
Good
a
afternoon.
doctor.
How?
I'm a doctor, cardiologist.
Ah, okay.
Yeah. It's
Yes, I work with
a very
doctors.
practical investigation, but did you have experience or implementation with investigation in our real practice, clinical practice?
And yes, now I want to
Your university have the biggest medical school.
Now I want to collect real data set from our 20th clinical center from Almaty, and I have model, and if they give me the data set, real data set, patients, real patients data set, I want to train model on this data set.
And how many patients in your data set?
Can you repeat, please?
How many patients in your real data set?
I think around 5,000. And
5,000 patients.
but I have 5 classes.
Ah,
Yes.
it's huge job.
Which class?
Maybe 500.
No, 5,000.
It's huge job.
5,000 images, and in one class, 1,000 images.
Which kind of classes? Like is acute failures? Yes.
Yes, like same classes, but one class ишемический болезнь.
I see. Ischemia, acute ischemia. Yes.
Yes.
Good. My congratulations.
Yeah.
Thank you.
Thank you.
And Nadra, we just want to continue our previous question that it is really, it seems that it's really hard to get 1,000 for each class, and in real life it is almost impossible, right? Maybe we somehow can squeeze this data and somehow change the model. If your model can train with less data set, how do you think? Is it possible?
With less data set.
Yeah, because in real life, it's hard to get 1,000 data,
Yes.
right?
I think the data set of Bangladesh Heart Organization, it's open source data set, and it's a very good data set. It's датасет уже хорошо обработано, поэтому очень хорошие показатели были.
Thanks a lot. It's very interesting, and it's very it's very actual and very relevant paper. So now we should move to the next presenter.
Yeah, you can stop sharing. Thank you for your presentation.
Okay.
Thank you for your
Thank
presentation. So Araylan Lyubaeva, Sultan Albakirov, they will present offline from our class. So please.
Oh, they are online.
Where is your presentation?
What Araylan?
Presentation, where is your presentation? No. So the next presenter, Ibrahim Aliyev, Gultay Muradova, Sama Mustafa Zada, Jusuf Mambayev, Pakizat Shamoy. Are you here?
Yes,
No.
I'm here.
Okay.
Just 1 minute. I'm gonna present.
Yes. Ibrahim, please turn on your camera For the requirement of our conference, you should turn on your camera. Greetings from Kazakhstan. So, and now we ask you to share your screen.
Ibrahim, we cannot hear you.
Do you see the presentation?
Yeah, we can see it very well. Now
Okay.
you can start.
Yeah, so hello everyone. I'm Ibrahim Aliyev, and today I'm honored to present our research titled The Public Perception of Feminism, the Sentiment and Emotion Analysis. And we conducted this research along with the, like you can see the author names here. This is a, the research was conducted both by ADA University and Kazakh British Technical University. And our supervisor was Pakizar Shamoi. So our motivation is feminism in essence is about achieving gender equality. We can say socially, politically, and economically, but in both media and society, feminism is often misinterpreted because sometimes it is confused with misandry. And that's why in the digital age, these conversations have moved to social platforms like Reddit. And it offers, I believe, it offers a rich source of public opinion. And our goal is to analyze how public sentiment, emotions toward feminism evolved between the years specifically 2020 and 2024. And we use advanced NLP techniques. And when it comes to our research contributions, I would list three of them. Firstly, we created a custom data set, and it uses the Reddit posts comments, and it from two time periods, 2020 and 2024, and we kind of created this data set using the feminism-related keywords. And secondly, we applied natural NLP methods, specifically sentiment, sentiment analysis, emotion detection, topic modeling. And thirdly, our findings, they can inform not only academic researchers, but also advocates, the policymakers who want to better understand and address the misconceptions in the public discussions. And for our related work, actually there has already been considerable work in sentiment and opinion mining across various topics like COVID-19, environmental concerns, and politics. And many studies use techniques such as random forest, SVM, to analyze the social media data. And when it comes to feminism, several researchers have already explored how it's discussed online. One notable campaign I would mention, the Visible Wiki Woman, and it highlights the under representation of women on platforms like Wikipedia. And our research, it actually builds on this foundation by not only applying advanced NLP tools like Distilbert and NRC-Lex, but also it creates a data set and compares changes over a span of 4 years. And this gives our study a unique perspective that many others actually lack. And for methodology, we firstly, the first part is data collection, of course. We used, for data collection, we used Python Reddit API wrapper to extract the posts, comments. And for that, we used specific feminism-related kind of subreddits, such as feminism, 2X chromosomes, gender studies, women's rights, and etc. And also to ensure the relevance, we filtered this data using the keywords such as feminism, gender equality, patriarchy, misogyny, and etc. And in total, we collected 194 posts and nearly 6,000 comments from the year 2020. And for 2024, the number of the posts were 1,700, which is more than 100,000 comments. And the second part of the methodology is actually the analysis of this data set. For emotion, we used NRC-Lex Python library, and it uses the NRC emotion lexicon. And this tool actually assigns emotion scores ranging from 0 to 1. And we specifically chose the emotions that are whose score is at least 0.25. And for sentiment, we use the Stilbert to classify each comment as positive, negative, or neutral. And for topic modeling, we used LDA, latent directlet allocation, and it let us to uncover the kind of dominant themes in the discussions. Yeah, and this is actually the workflow of ours, the pipeline. We firstly parse the posts and comments using the keywords, and then we apply data preprocessing. We finally collect the data set and apply the analysis, sentiment, emotion, and topic modeling. And when it comes to the results, we can see that sentiment trends between 2020 and 2024, we found a noticeable shift. In 2020, sentiment was some kind of mixed, like about 49.4% of comments were actually negative, and I would say 33 were positive, and the rest were neutral. However, in 2024, the number of the negative comments, it actually increased to 54, and the number of the positive comments, they slightly decreased. Yes, this was the result of sentiment. And for emotion analysis, we saw some consistent patterns and some important changes. In both 2020 and 2024, the dominant emotion was trust, which is actually encouraging because it suggests that despite disagreements, many users still engage in these conversations with some level of openness or believe in the importance of the topic. However, in 2024, emotions like anger and fear increased, and these emotions reflect kind of rising emotional tension in these discussions. And it suggests that while conflict is growing, so is the support and solidarity within certain feminist communities. Yes. And when it comes to implications of our findings, so actually what all these findings mean. Firstly, as I mentioned, the rise in sentiment, negative sentiment and emotions like anger and fear, they highlight a growing need for clarity and education around what feminism actually stands for. Advocates and policymakers actually need to pay attention to these emotional shifts. Also, if people are feeling threatened or misunderstood, outreach strategies need to address those perceptions directly. And also our findings suggest that better communication, inclusive messaging, they actually could help counter misinformation and stigma in the society. And most importantly, we have shown that online discourse is not static, it's actually dynamic and it changes over the time. And tracking it actually gives insights how public movements like feminism are perceived and shaped over the time. Yes, and finally, when it comes to conclusion and future work, as I mentioned, the public perception is dynamic. It changes over time. This was the main insight. And also, we observed that Reddit and the platform itself, it actually provides real insights into the real-time attitudes. And for future work, we actually plan to expand our data set to extract posts from not only Reddit, but also from Twitter, Instagram, TikTok, and etc. And one more thing, we plan to create our own custom model, sentiment and emotion models, to analyze the data. Yes, and thank you for listening.
Okay, thank you very much. Yeah, dear participants, do you have any questions?
So I have a few questions. Thank you for your presentation. So the main thing you have mentioned that you're using the BERT model, yeah, for the feature extraction from the textual data. And then do you have some evaluation metrics for your model? How we can measure?
Yes, we use the Stillbird for the sentiment analysis. And like, no, actually, there is no any evaluation metrics. I would say so the model analyzed the comments and gave negative, positive, or neutral tags to each comment, and according to the number of the positive comments, negative comments, neutral comments, comparing to the whole data set, we just like we got the percentage.
Okay, that's clear. Thank you.
And we have one more question. I just want to ask, so I'm curious about, you have taken all those data from open social medias, right? And sometimes we do know that social medias already have sensors that they will automatically filter the comments about racism, about any diversity, I don't know, classes, right? And to avoid these terms, to avoid these conditions, most of people will express their feeling not in that way that we think. For example, they may write as a very good, I don't know, very good lady, right? But by the word very good lady, they can mean the different thing. Then how you did you face with this kind of things, or how you will deal with this kind of comments?
Actually, we used filtering, as I mentioned in the data collection part. We used keywords: feminism, gender equality, women's rights, patriarchy. Like these keywords helped us to filter the data set to get what we really want in order to gain some valuable insights. But of course, yeah, probably the situations that you mentioned also exist, but we try to avoid it by using the keywords that we actually need.
Okay, okay. Thank you. Then thank you very much. Thank you, Ibrahim, for very valuable presentation. Yeah, let's give a speech for our next presenter with ID 405. Yeah, Dmitry. Daniel Hamza. And we have in-person presentation. Could you stay over here because our microphone is. You can start.
So, good afternoon, dear audience. My name is Hamza Daniar. I'm a student in Astana University, and today I want to present my work on model forecasting methods for precision irrigation management using space monitoring data. This paper was written joined by Dmitry Son and our supervisors, Ms. Svetlana Belchitskaya and Mr. Alexander Chansky. So, agriculture is one of the main economic spheres of our country, and precision irrigation management play a crucial role in agriculture sphere today, especially in our region, because we have drought for summers and the snow for winters. So this kind of irrigation management become one of the main interests for farmers to increase their productivity of their field. So our work will focus on precision irrigation management using space monitoring data, especially as some satellites, imaginary, and joined by some meteorological data. First of all, we analyze current models and methods for precision irrigation management, then we collect and analyze processes, input data, such as I already mentioned, settlements measuring, investment, and fuel data. Then we develop and validated advanced machine learning models for precision irrigation management needs, conducting testing of our model, and now working on practical implementation of using our optimal model. So if we talk about literature review and previous work that focused on this area, we see the Arabian work, which used some US multispectral imaginary data sets, and most of this work are focusing on some data fusions, some multi-sensor, drone-based, or sensor-based. So also, we want to mention work by Nguyen Hiel, who developed model with a lower cost for machine learning approach to predict soil moisture. So our research novelty is about to use multi-source space monitoring data integration and combine it with advanced machine learning techniques. So let's move to our model input and how we process and what we get as a result. In our model input, we had satellite image provided by Sentinel-2 is one of the best decision for satellite imagery, especially for agriculture. Then we use meteorological data which was provided by the Open Meteo and soil moisture data, which was grabbed from Planet. Some of this data is proprietary, some of them are open source based. And in the result, we get output of soil moisture prediction. We predict soil moisture for 7 days life, for 14 days life, and then in the end for 30 day life. This is our slide for exploratory data analysis. It shows the correlation between daily temperature and the EMEA measurement. EMEA is normalized liquids moisture index that we used as a target index for our model training. Yes, there is one more slide. I will talk with our audience, but I don't think it's visible for this arts. So we built a LSTM network, long short-term memory network, and we use it for three branches. Three different branches, one with the laser branch data, one with satellite branch data, and cloud features. Why we use this architecture? Because LSTM is most suitable for our case because it can capture long context data. And for example, we use like just SARIMA models or ARIMA virtual models, which was present only for seasonal for capturing seasonal data. Our LSTM model squarely because we can divide it into three branch, use forget gate, use memory to capture more context, to capture anomalies better, and in the end to get a better result. So as I said before, we have three branches. Weather features, which include temperature, daylight duration, precipitation time, and also average duration. Several features we have several features we count agricultural indexes such normal vegetation index, normal moisture index, and also case irrigation indexes. So we have about features for you can model result can differ for some agriculture culture classes for also like the irrigation type and so on. Most of our data set was collected for our North Kazakhstan and East Kazakhstan region. In the end, we combine all of this branch or one branch, convey them, and drop it out to prevent our model to overfitting. And in the end, we get a result for soil moisture. Resulting discussion. So this evaluation method for our models is mean absolute error showing 0.23, and while root mean square show 0.37, and we have also R squared, which show around 50%. I know that it's not the best result, but now we're working on to improve it because we need to gather more data, and also because we used our custom network, we can now to improve this result. We also thought about using some training data, but unfortunately, they're not suitable for our region because Kazakhstan fields are much bigger than fields, for example, in Europe, and most training models for agriculture sphere is focusing on the European cases. So this graph shows distribution of true values distribution. You see that our model captures distribution of data well, and patterns are visible here, but we see that we need to improve our accuracy, especially in more how it's called in database with lesser soil moisture values. When we talk about bigger soil moisture index, we see that models capture this data better with the lesser. In the conclusion, so we integrated Sentinel-2 irrigation. This is our framework demonstrates significant potential because we want to provide our results in the future because this agriculture season with one of the biggest agriculture holding in Kazakhstan, I guess, and in the end of the season, I guess we have better models and better irrigation for our Kazakhstan. Thank you for attention.
Yeah, thank you very much. Dear participants, online or in-person participants, do you have any questions?
So, for your data from the satellites, how do you collect it then? Is it an open source data? Or?
Yes, Sentinel-2 is a satellite that was launched by European agency, and it can provide open source multispectral satellite imagery for each region. You can get it. It's open source.
Okay, and what regions do they cover?
They cover whole world. Yes, whole world.
Kazakhstan?
Yes, including Kazakhstan. It's like open source. You can connect them through Copernicus IPA.
And what kind of features do they provide?
They provide just image aid with multi-band spectral images, and you can calculate your, for example, satellite for agricultural indexes by your own by using like equation, for example, for index calculation. It's multi-spectral and multi-band, so they have 8 band, each band show their own values.
But in your work, you're not using the features from the images.
No, I used.
So you provide MSTM?
Yes. Yes, this slide. All of these indexes, agricultural indexes, was calculated by preprocessing image from the satellite.
Okay, and how do you preprocess the images?
So we take image, then take how to extract data from the each band, and then for each of these indexes we have our own equation that was standard equation for all of this index, and then we can calculate it. So you extract image show you numerical data. For example, near interface radius index or like green index and green band. I mean band, yes. And then you can calculate values by your own, index by your own.
And to work with the images, which algorithm did you use? CNN-based approach?
No, it's not about. It's as I said before, it's not just image like JPG or PNG. It's multispectral. So you have 8 bands of images, 8 layers, I guess, and they present like numerical data. You can extract them and work with like table-based data. It's not about like computer vision. It's not about. So that's all. Thank you for attention.
Next is Azat Aldeshov. ID 423. Oh. Anshar Amanul Rasapur. No. Okay, then the next one is Janbay Uzdembayev. Okay, then
Yes, we can hear you. What is the paper ID?
ID 24.
Okay. Please share your screen and you can start.
Okay. Just a second. Okay. Shall I start?
please.
Hello, my name is Birlik Minabayev. I'm presenting paper ID 24, Applying Advanced Analytics and Natural Language Processing to assess the effectiveness of political rhetoric case study of presidential message in Kazakhstan. Okay. Can you hear me? Hello. The objective is to analyze presidential messages for 30 years and identify key themes, emotional tone, and trends, and also compare rhetoric with public healthcare indicators. We used data from 28 presidential speeches in Russian, and we explained in the article why we use Russian language. We used we analyzed over 1 million words, 25,000 plus unique terms, and healthcare was selected as focal sector for correlation. We used methodology which included text processing, frequency analysis. We used tool Voyant and also some programming on Python. Also, we used models LDA and correlation analysis. As for theoretical framework, we use critical discourse analysis, agenda setting theory, policy feedback theory, and framing theory. The main tools we used was Voyant tool for visualization and the Python for programming, and also Vader for sentiment classification. Our key findings: frequent themes, development, obligation, national health, and health rhetoric spiked during COVID-19. Strategic slogans were also repeated across speeches. As for lexical and emotional insights, we demonstrate that there was a decreased lexical diversity post 2010 and predominantly neutral positive tone in all speeches. Emotional shifts during crisis years. Results: economic development, health care, national identity, governance, and anti-corruption were analyzed. And we found that correlation in rhetoric and spending is weak, or moderate correlation in rhetorics and versus life expectancy, and spending increases, but often reactive, not strategic as planned. Conclusions: presidential rhetoric is symbolic and reactive, a limited assignment with actual healthcare outcomes, and NLP reveals gaps between discourse and implementation. Next step for our research is expand analysis to other sectors like education and economy, and make cross-country comparisons of political rhetoric and integrate public sentiments and media reactions. That's it. Any questions, please?
So have you used the pre-trained models for the NLP task?
Not really, no. We used data analysis, deep data analysis.
Okay, and how do you evaluate your models then?
We compared, we made correlation analysis between rhetoric and factual macroeconomic level indicators.
Also, you have mentioned that you can integrate it with the healthcare. So how we can do that?
Well, we took deep analysis, statistical analysis on healthcare indicators, and then made special search on rhetoric using special words like in Russian здравоохранение, продолжительность жизни, some kind of all words related to healthcare, and spendings related to healthcare. And then we did comparison.
Presentation.
Say again.
So the next presenter is, do you have ID 28?
Well, I can share the ID, but presenter will be Perizat Bulubayeva. They should be online, or Tamerlan Mendebayev.
Perizat, but I'm not seeing her here among the participants.
So Tamerlan Mendebayev, well, they are co-authors, and I have, well, she is up here, Burbayeva Perizat here. I'm helping them with technical stuff because they are not in Astana. Perizat, hello.
Hello, everyone. Can you hear me?
Yes, I hear you, but
can you start?
Wait a second.
Let you share, yeah.
Yeah.
Perizat, before starting, please keep our time limit, yeah? 5 minutes for your presentation.
Yeah. Oh, 5 minutes, okay. Hello, everyone. My name is Perizat Burbayeva. The topic of our presentation, insights for regional development planning in Kazakhstan. Next slide, please. According to official data, Kazakhstan has reported an urbanization rate of approximately 65%. However, this figure is primarily based on administrative classification of urban and rural areas, many of which are outdated and longer reflect the actual spatial patterns of settlement and land use. As a result, the current urbanization rate may be overestimated or misrepresented. Administrative boundaries often fail to account for suburban growth, informal settlements, and functional urban areas that extend beyond city limits. This creates a discrepancy between the official status of locality and its real urban characteristic. To address the geospatial methods, including satellite imagery analysis, population density mapping, and the Degurba classification system, provide more accurate and objective insights into the true extent and structure of urbanization. Degurba, it means degree of urbanization. These tools enable planners and policymakers to access urban growth based on actual and land use and population distribution rather than outdated legal definitions. Next slide, please. Next slide, objective and methods. Thank you. Objective. The study aims to resist urbanization in Kazakhstan using modern geospatial tools for more accurate data-driven understanding, moving beyond outdated administrative boundaries to reveal real settlement patterns. The Gurba methodology classifies areas as urban centers, urban clusters, or rural based on population, density, size, and spatial continuity. Uses uniform 1x1 grid to identify urban patterns beyond city limits. Satellite data, GHSL, maps built-up areas and monitors urban growth, helps detect informal settlements often missed in official stats. Next, population and built-up area analysis combines land use and population data. Assesses density, land consumption, and urban threat. And this integrated method enables a multidimensional view of urbanization, capturing both where people live and how the land is used. Next slide, please. Data sources. Berluk. Data sources, okay. The analysis is based on multiple high-quality data sources. Key data sets include the global human settlement layer, which provides detailed information on built-up areas and population distribution. Satellite imagery is used to detect and map urban expansion, and population data is drawn from 1990 and projected 1995 population grids, offering insights into demographic changes over time. This research is further supported by data sets and tools developed under the European Union and Copernicus programs, which ensure consistency and accuracy in geospatial analysis across region. Key finds. According to official statistics, Kazakhstan reports an urbanization rate over 65%. However, when applying the DigUrba methodology, which classifies areas based on population density and special characteristics, rather than administrative status, a different picture emerges. The actual urbanization structure based on DigUrba is as follows. Urban center, 46% of the population live in high density, highly connected urban areas. Cities with greater 1,500 people per square kilometer and a population over 50,000 residents. Urban clusters, 32% of the population live in moderately dense areas, often including suburbs and small towns, areas with greater 300 people per square kilometer and at least 5,000 residents. And rural areas, 23% of the population reside in low-density settlements with less than 300 people per square kilometer. This breakdown indicates that the official rate likely overestimates the true level of urbanization, as it does not account for the spatial form and function of settlements. Next slide, please. Spatial patterns of urbanization in Kazakhstan show uneven development. The distribution of built-up areas across different types of settlements is as follows. Urban centers cover a total area of 547.8 square kilometer with an average of 59.6 square meter per person. Urban cluster occupy 755.3 square kilometer with 919.6 square meter per person. And rural areas account for 1,064.2 square kilometer and with a relatively larger 233.7 square meter per person. This data highlights the variation in land use density between urban, semi-urban, and rural areas. Next slide, please. For example, case study Karaganda region. The Karaganda region in Kazakhstan serves as an important case study for analyzing urbanization and spatial development. The city itself has a high population density and extensive built-up areas, meeting the previously mentioned criteria. The areas surrounding Karaganda include urban clusters and rural zones. These zones consist of small settlements of suburbs that are functionally functionally connected to the city, but don't meet the population density threshold to be classified as urban centers. Some of these areas fall under the category of urban clusters, while others are still considered rural. Official urbanization data in Kazakhstan are often based on administrative boundaries that don't reflect the actual spatial development patterns. For example, the suburbs of Karaganda may be classified as rural, despite active development and increasing population density. This leads to an overestimation of urbanization levels, as the current system fails to capture informal settlements, growing density zones, and functionally urban areas that are officially considered rural. The case of Karaganda highlights the need to update urbanization assessment methods, taking into account functionally urbanized zones that extend beyond formal city boundaries. And next slide, socioeconomic insights. Okay, thank you. Urban clusters face a lack of infrastructure and economic autonomy. These areas often lack essential services and depend heavily on larger cities for resources and employment. And wrong classification causes a resource misallocation. Misclassifying urban clusters as rural or semi-urban leads to inadequate infrastructure development and inefficient allocation of resources. Projection and policy by 2030, urban centers are expected to exceed about 10 million people. A decline in rural areas is likely due to continuing urban migration. Recommendations: support mid-sized cities. Focus on strengthening the development of smaller cities to prevent overcrowding in major urban centers. Improve rural services and connectivity. Enhance infrastructure, healthcare, and communication networks in rural areas to prevent further decline and improve the quality of life for rural population. And conclusions. True urbanization about 46%. Official data overestimate urbanization rates and they rely on outdated administrative classifications. Recommendations: use geospatial data for more accurate urbanization analysis and planning. Redefine development priorities based on actual urban growth patterns rather than outdated statistics. That's all. Thank you for your attention.
Thank you very much. Presentation. And any questions from this? Can you come close to the microphone? Yeah.
Irizat, thank you for the presentation. And I have one question. Which resolution does your satellite imagery have that you use?
This application has a practical implication of our research. Our research helps policymakers and urban planners in Kazakhstan better understand the real spatial distribution of urban and rural populations. And by using geospatial data and the DEGURBA methodology, we provide a more accurate picture of urbanization, which can be used to, for example, improve infrastructure planning or target regional development funds, avoid resource misallocation, maybe support sustainable urban growth and other.
No, thank you, but I mean, other thing, I mean, which resolution does your satellite imagery that you use satellite imagery have? I mean, 50 meters, 10 meters, 100 meters?
This methodology, the DEGURBA methodology, and
especially in
100.
Oh, thank you.
Okay.
Any other questions? Okay, then thank you, Lisat, for your presentation. Yeah.
Thank you.
And for the next presentation, we would like to invite presentation of ID with ID number 391. Yeah? Sultan. Hi, Sultan. Please, you can start. Presentation. Co-authors from Astana University and one professor from Nazarbayev University, Aday Shuman, co-author for this presentation. Okay.
During the previous research, we have faced several issues with the Kazakh language related data. When we have conducted various research, our LLM models, faced several issues when facing with Kazakh related text. So we have aimed to solve this issue, creating small Kazakh language corpus, and with several objectives. We should gather the data, clean the data, and then we have laid the models whether they improve or not. Then we have found several data sets which are already exist in calculated sphere. For example, CAT4T from IIS. It is a another university institution which has more than 4 billion packets. Then we found their models, which are multi-language, are aimed to be multi-language, but they gather data only from Kazakh Wikipedia, so it's limited data, and we aim to improve the amount of Kazakh-related data. Then the INSAI also faced an issue. They had the language model, and the limited amount of data. Also, they gathered the media resources, the papers, the news, and so on. Also, we processed data. Then this our pipeline creating the data set. First of all, is to gather the PDFs and using OCR to collect text from the PDFs. Then restore layout to give the order of the blocks, and then clean and use this data globally. As you can see, we collected almost 11 gigabytes of data. It's a raw data, PDFs, articles, news, and so on. We can use several sources, like websites, repositories of papers, libraries, and so on. On the right, you can see the example of the one paper in this PDF. You can see that there are several categories of data, like plain text, tables, and headings. We can use the marker PDF to gather the data from the PDF. As you can see from data, the marker PDF, the LLM feature, is enhanced version of the marker and the better version of Gemini Flash. Then, when we gather the data, we have several categories of data. We chunk the PDF into several categories, like text or headings, tables, and so on. As you can see, we separated the tables in chunks, and the headings, subject heading, for example, and the plain text to use to make the usage of the data set more convenient. Then we can analyze the length the data. For example, the data which length is between 20 and 40 decibels is kind of useless because it contains personal information or the ICBMs, nor the city name, and a lot of user data. So we have deleted this information from our data set. Then we duplicate the data set using the vintage algorithm, which takes the two strings, finds the similarities of the strings, and indicates if the threshold is or pass. Threshold is 0.8. As you can see the graph, we have a lot of data whose length less than 1,000, but also we have the paragraphs whose length is equal to 40,000 symbols. It's a distribution of length. Then we use the data set to train the models, for example, XLM Roberta and Roberta language, and as you can see, there is 20% gain in performance. For example, XLM Roberta, without our data set, took only 48%, but after the fine-tuning without the set, took 68%. In conclusion, I can say that we have created the clean data set, which uses several categories with sex, with tables, with feelings, and so on. And also have shown that our data set improves the results of the model, large language models. And this data set is open source, so you can find this on Hugging Face, download it, and see the actual results. And
Okay, thank you very much for the presentation. Any questions from audience? Do you have questions?
Okay. So you fine-tuned the model, which was already presented by the SI.
Yeah, by SI and by another professor.
And this data set on the Hugging Face, did you collect it?
We did not train the model from SI. It's an open model from the Hugging Face, sorry.
It was a model from Hugging Face, okay. And what was the number of parameters for this one?
The large model, XLM Robert Large, as I remember, is 7. Oh, sorry, no. 500 billion, as I remember.
For both of them?
No. The XLM Robert base is larger than the Robert is large. I don't remember the exact number of parameters, but they're almost like 3 or 500,000 millions parameters.
Okay. Yeah.
Okay, thank you very much. Please proceed. I see. Next.
No. ID 423.
ID 423 we presented. Azat Aldeshev, from Kazakh British Technical University, Kazakhstan. You cannot see this, any of this co-authors or presenters of this ID. Then you can wait a bit, but then for a while we can proceed with the next presentation, ID 346. 364. Excuse me. Jambay Uzdembayev. And Ruslan Amirgaliyev. Ruslan, are you ready?
Yes, do you hear me?
Yes, you can hear.
Okay, let me share my screen. Do you see my screen?
Yes.
Okay. 1 minute. Yes. By the way, the topic of the research was slightly changed after the suggestion of reviewer. Now it is deep peer-based learning for closing style matching with the instant and the CMS model. So here you can see the content of the presentation, which includes introduction, literature review, methodology part, results and discussion, and conclusion part. So deep learning and fashion pairs are able to create new tools that help us users to improve their personal style, choose outfits, and help them to optimize their wardrobe selection. In fashion applications where details like texture, color, and shape affect on style choices, then set architecture, which are frequently used in visual data analysis, must be highly effective at identifying detailed features from images. Accurate compatibility prediction is made possible by the instant's ability to efficiently capture visual patterns through the analysis of diverging clothing images. And then also fashion compatibility prediction technology has advanced, but many systems still struggle to capture contextuality, rich and diverse data. There exists also imbalance fashion data sets. It's a serious problem. Categories like formal outfits or seasonal outfits that may be underrepresented. So that's the case here. The main study objective as of this one is to develop compatibility prediction framework, combining DenseNet and CMS neural networks, and focus on pair-based style matching and detailed visual analysis for fashion. And at the same time, in this paper, it was used the NRS and then neural networks, which compare clothing items to assess visual compatibility, improve recommendation accuracy by learning style-based pair-based relationship, and enhance the wardrobe experience through similarity-based outfit suggestion. Here you can see some examples of how the compatibility prediction can work. And also here in the scale from 1 to 7, you can see different types of ratings, like confidence, success, salary, flexible personality, and so on. Now if we'll go to the literature review part, so there is lots of course, research works in this area. So for example, the first literature work was about the DNN architecture that uses special connectivity pattern to improve the gradient flow and feature reuse. Intuitively, each layer in DenseNet receives all preceding layers' feature maps as inputs in place of merely the last layer's feature map. The second research work was about providing innovative treatment of the potential use of SNN for one-shot learning problem. The network is composed two precisely the same and weight sharing networks. So these networks are taught in such manner that they maximize the separability of the embeddings. And in the third work, you can see some examples of different nations as of flows in which they're trying to find some patterns with different attributes also here. Another literature review is about solving category compatibility, showed a novel framework that uses CMS neural network to compare items that pair well across various clothing types. So they achieved some results for different types of outfits, like 67% for shirts, approximately 48% for shoes, and for jeans also. Now, if you go to the methodology part, so here, of course, the main goal which we're setting up, even from the introduction part, is to predict outfit compatibility using some deep learning techniques. As a data set was used, open source data set from Polyvore. So here, we also did some main key steps like data pre-processing parts, like preparation and cleaning. Then the next step was model building. Then the third step was model training and evaluation using different types of evaluation metrics like accuracy, precision, and recall part. Some description of data sets. Here we can see the structure. So total we have approximately 251,008 items. Out of them, 68,000 is outfits, different types of fine-grained categories, and 19 high-level categories. Also, it was split into training, validation, and testing sets. So here you can see the numbers. Also for the discussion part, it was used another variation of that data set, which is called as outfit D, or D means here disjoint version. So disjoint means that no item overlap between splits. So here you can see some graphs of them. Then after description of data set, here you can see other methods like data cleaning. So here we remove non-fashion items like furnitures and so on. And there was data transformation. So we had different types of images, and we have some resizing of images to 224, 224, and 3 to RGB, red, green, blue part. Different types of techniques can be also applied, like cropping, flipping, or color jittering part. all images was normalized to 0 and 1 cases. And at the end, we can be sure that we are using uniform distribution. So our data set was balanced. Here you can see 0 or 1 cases. Then, and the next part is about the whole architecture, so shared chain extract visual features. DenseNet used for feature extraction. Here you can see exactly the content of the architectures. In the first layer, we have 1024 units, batch normalization, and some activation function. And this is, by the way, the equation of that leaky ReLU. In the second layer, the number of units was decreased. The same optimization activation function was used. This relates to some discussion about why exactly CMS neural network, because we see that experience that it was designed for similarity comparison task. It's using shared weights for efficient feature extraction, proven effective in-phase verification, product matching, and enhances model generalization for compatibility prediction. Also, at the same time, by experimentally, we tuned some hyperparameters, like learning rate was chosen exactly in this range, like 10 to the power of -4. Then batch size was also chosen as 32. The number of epochs was 22. Initially, it was 10. And then some regularization procedures like drop out and reach L2 regularization. Here you can also see the mathematical equation part. All of these techniques was used exactly to prevent any overfitting problems. Here you can see the final model architecture, which is used exactly all above things for the following closing categories like bags, outerwear, shoes, tops, and bottoms.
Well, sorry to interrupt you. We have time limits, unfortunately. Can you proceed to conclusion part? Yeah.
Okay, yes. So here the evaluation metrics, which you can see the result parts, like different loss, accuracy, precision, recall part. So initially we had accuracy at the level of 75%. Then this is the conclusion. So the combination of using DenseNet plus SNN applied for outfit compatibility prediction. Model achieved some moderate accuracy at the level of 75%. But we also have some recommendation for improvements, like we should use advanced regularization technique. Maybe it's necessary to use feature extraction architecture. Again, try to use different tuning hyperparameters, and maybe even expand the size of the data sets for good flexibility part. That's all. So this is the list of references, and thank you.
Thank you, Ruslan, for your presentation. And dear colleagues, any questions for presenter?
So one question from me. So you have used the CMS network after extracting the features from the DenseNet, and how does CMS calculate like the similarity score? Like you are passing 2 elements, for example, and then
Yes, so here, if you look at this part, initially this compatibility score was given like as a true data. So for example, the combination of these 4 of them based on the opinion of different people they can have, for example, some value between 0 and 1. So the neural network knows that this is the true information. And by using different combinations, he's trying to also find some average value.
So what is then the maximum output from the network? Like, can we add 10 items of the like clothing?
No. There also be some limitations, like combination of only 4 or maximum 5 categories in one clothing, because we cannot have clothes with 10 items, as for example. That's the case. Limitations we can have.
Okay, thank you very much.
Thank you. Okay, then let us proceed for the next presentation. But again, I will call presenter with ID number 423. Are they participating? Yeah. As I can see, they're not participating. Yeah. Then from the today planned scheduled presentations, we listened them all, excluding this last presentation 423. And thank you very much for participating, attending our conference section presentations. Yeah, and maybe according to the section plenary session is not will not change, then it is planned for the 6 p.m. clock for closing ceremony, and final conclusion maybe reports will be given by chair of the conferences. And, but for regarding our sectional presentations, we completed our schedule, our plans. Then maybe some few 2-3 ID not presented. Then maybe if they contact us, then we can hear them. Yeah. Okay. Then thank you very much. Then I'll see you in conclusion of calendar session. Yeah.
Congratulations.
Yeah.
Thank you.